I get a lot of questions about distributors. What kind of distributor do I use? What kind of distributor should you use? It's not really a straightforward question to answer. So I think what I'm going to do to help you make a decision, if you're interested, is to show you what your different options are and talk about the pros and cons of each. You do have a lot of options when it comes to distributors. You can really group them into, I think, three categories. We won't talk about magnetos. That's pure racing. That's a different category. But for your regular road-going auto engine, we have a points type distributor. We have an electronic distributor, and then we have a category, I'll call it a trigger. It looks like a distributor, but really it's just a trigger for a fuel injection system. You don't even need it at all. You could run a crank trigger if you wanted, but they're a great option for allowing you to upgrade to, say, a multi-point fuel injection, sequential multi-point fuel injection, with relatively little modification to the engine. So we'll sort of look at those three options, and I've got an example of each. So we'll make our way over to the workbench here, and I'll show you what I got. So on the left here, this is a single point distributor, vacuum advance single point distributor. If you're messing with an early 289, 302, 260, 221, anything basically that came out of the factory in the 60s probably would have had a single point vacuum advance distributor on it. There are variations of this. You've got dual point distributors. You've got some that have adjustability for mechanical advance and other options. But so this is your basic stock distributor. Next up, this is an MSD Pro Billet distributor. This is an electronic distributor. Instead of using a point in order to determine when to fire the coil and provide a spark, it uses an electronic pickup mechanism and an external box to trigger the ignition. I'll talk more about that in a minute. And then this last one, this is a dual sync distributor. This is purpose built to work with a fuel injection system, and it has a crank trigger and a cam trigger, essentially, so that the fuel injection system knows when the cam has made one full, or the cam has made one full revolution, and it knows when it's aligned with each of the 8 posts to fire the ignition. And so this just gives input to the fuel injection system. The fuel injection system controls everything, when it fires, the amount of timing, and it has complete control. So that's sort of the third category. Not really a true distributor, although it does have a cap on it. You could actually use one of these distributors just purely as a trigger and run coil on plug if you wanted to. I'm going to start back with the single point distributor and talk a little bit more about the distributor. As I mentioned, it's the factory distributor you'll find on pretty much any car from the 60s. And they are extraordinarily reliable. If you've got yourself a 65, 66 Mustang and it's bone stock and you just take it out and drive it to the cruise on a Saturday night and occasionally take it out on a parade, if it's got this in it, keep it. Don't ever replace it. You don't need anything other than this. All of the other distributor options will give you power improvements, but they will not give you reliability. If you're interested in reliability and reliability only, this is it. You cannot beat this distributor. It has a single point in this particular one, although there are dual point options. That's this guy right here, and when it opens and closes, and that's how it triggers the ignition to fire. There's an 8-sided cam mounted right here on the shaft, and so every time it comes around, it bumps the point at 8 different points on the revolution. So the point will be closed most of the time. It opens every time one of the ramps on the cam hits it. And that's what's used to trigger the ignition coil to fire its energy through the plug wires to the spark plug. So it's no external connections needed. There's typically just a single wire connection that comes off of here, and that's it. Now this one does have a little bit of, I'm going to put the rotor button back on so you can see a little better. This one does have a little bit of mechanical advance built into it, so I'm going to hold the main shaft so it can't spin. And so the main shaft isn't turning, but the rotor button can turn a little bit. So it can turn counterclockwise, and it's spring-loaded back to its original position. Small block 4 distributors rotate counterclockwise, and so if this were say 0 degrees on the balancer right at top dead center on compression stroke, this would be slightly advanced from that, and it can move based on centrifugal force. So the higher RPM you reach, the more this will move. So that's mechanical advance. But it also has a vacuum canister here, and I happen to have a little handheld vacuum pump here, so I'm going to connect that to the distributor, and I'll pull the rotor button back off again so you can see the whole plate when vacuum is applied rotates. I'll do it a few times so you can see it. So when vacuum from the engine is applied to the vacuum canister, it advances the ignition timing. And for the purpose of this video, I'm not going to go into advanced curves and how to set an advanced curve, and I'm definitely not going to touch the internet's latest debate right now, which is whether to connect this to manifold vacuum or timed vacuum on the carburetor. I definitely have my opinions on that, but I'm not going to talk about that right now for the purpose of this video. So that's your basic single point vacuum advance distributor. A little bit of mechanical advance built into it. It's not adjustable at all. And then some vacuum advance. And you put this guy in, you stab it in at top dead center, advance it just a little bit, set it with your timing light, and forget about it. The only maintenance you'll have to do over time, every time the point opens, it arcs a little. If you were actually watching it when it occurs, you'll see a spark. And so over time, carbon's going to build up in there. And all you have to do is just hold it open and stick some sandpaper in there or a file and just clean the two tips. Back years ago when I used to run one of these on my Mustang, I used to keep a piece of sandpaper wrapped around this wire, and I'd stick it down in there, and every now and then I'd pop the cap off, I'd pull my piece of sandpaper out and just put it in there, and then just keep it off to the side. I actually kept it inside the distributor. Of course, in the old hot rodding days, everybody smoked back then, and everybody had books of matches on them, and you could get a book of matches at any restaurant, and so you could use the striker off a book of matches to do it as well. But that's about the only maintenance you ever have to do on one of these. Put it in, set it, forget it. Every now and then, go ahead and check your point gap and the dwell if you got a dwell meter. But I wouldn't even worry about dwell on just a factory stock application. So nothing wrong with these. If you're running one of these and it's just your cruiser that you're just running around town to have fun with, you don't need anything more than this. And you certainly don't need the complexity or the potential for failure that comes with more complicated ignition systems. So just a single point distributor, vacuum advance, and a coil, and you're off to the races. Okay, next up is our electronic distributor. Now, the electronic distributor uses this little ring here. It's just steel tabs, one of them aligned with the position for each of the 8 posts on the distributor cap. And this blue guy right here is a sensor. Now, this is what's called a variable reluctance sensor. And a lot of people think it's a Hall effect sensor, but it's not. Variable reluctance is a little bit different than Hall effect. I'll explain that in a minute. But this is a variable reluctance sensor. What it is a permanent magnet that's wrapped in a coil of wire. And these tabs are just, this is just made out of steel, ferrous steel, so it's subject to magnetic waves. Now, the permanent magnet that's in here is wrapped with a coil, and anytime you move steel in relation to a magnet, that affects the magnetic lines of flux. So if you've ever done that experiment in school where you put a magnet under a piece of paper and then shake iron filings on it, and you can actually see the magnetic waves. Right now, the magnetic waves are being emanated from a permanent magnet inside this blue housing here. It's happening right now. And every time one of these posts approaches it, it affects that magnetic field. And the magnetic field, when the lines of flux are drawn through the coil of wire, that generates electricity. It creates a little bit of current flow. And what's interesting is the current flow will be in one direction as the post approaches the sensor, and then it'll be in the opposite direction as the post moves away from the sensor. So this is in effect an alternating current generator. So as the post approaches, it'll generate electricity in increasing magnitude until the post is directly aligned with the magnet, and then as the post moves away, that electricity will diminish and it'll move in the opposite direction. So if you looked at it on an oscilloscope, plugged it into an oscilloscope, you're going to see a sine wave. So the wires are connected, in this case, 2 wires. That's how you can tell it's not Hall effect. So a variable reluctance sensor will always have 2 wires. Hall effect sensor will always have 3 wires. So the 2 wires on this distributor have to be connected to an external box. Now, I mentioned this is an MSD Pro Billet distributor, but the Ford factory electronic distributor works in this exact manner with a variable reluctance sensor and the 2 wires. In fact, you could, if the need arose and you had an emergency, if your MSD sensor failed and you happen to have a good Ford unit around, you can bolt it right in here. It will work. It is in fact identical in physical dimensions. So it will work if you put a Ford variable reluctance sensor out of a DuraSpark distributor in an MSD. So they work the same way. So on the Ford, on a Ford car, when they installed these electronic distributors, they put with it what they called the DuraSpark module. And the DuraSpark module receives the signal from the distributor so that it knows when the posts are lined up for a particular cylinder or for any cylinder. And when that occurs, the circuitry inside this box basically acts as the breaker point and triggers the coil to fire the spark to that cylinder. And it does that 8 times per revolution of the distributor, once at each post. So you could run an MSD distributor, for instance, with a Ford DuraSpark box. MSD makes an adapter that goes from their standard MSD connector to a Ford plug. If you want to upgrade, you could go with an MSD box like this 6AL here. A 6A would work fine. The only difference is the 6AL has a rev limiter built into it. Or if you wanted to get really fancy, you could use the new Digital 6 that has 2-step rev control. And then any standard coil will work here. So now, you may have noticed this distributor does not have a vacuum advance module like the points distributor did. The way that this distributor controls the timing is through the use of these flyweights. Now again, I'm going to hold the main shaft of the transmission, the distributor, hold the main shaft of the distributor, and I'm going to move these flyweights, and when I do, you can see the whole plate moving. Now the main shaft of the distributor is not moving, just this top plate is moving. And so what that allows for is, again, if it were aligned exactly at 0 degrees right now, when the flyweights come out, you see it rotates counterclockwise. That's going to advance the timing. And a distributor like this does it completely mechanically through these 2 flyweights. It has 2 springs on it, and you can change the springs. They have a whole bunch of different options of springs you can use, a bunch of different combinations. I have 2 of the heaviest springs on here right now, just no reason, they just happen to be on here. But you can use a heavy spring and a light spring, a heavy spring and a medium spring, 2 mediums, 2 lights, whatever you want to do. You've got full adjustability over what RPM these flyweights come out at. So if you want a lot of timing to come in early, you'd put some light springs in it. As soon as you hit the gas and the RPM increases, the flyweights will fly out, and you'll get a lot of timing. If you want it to come in really late, you can put 2 heavy springs like this in, and these aren't going to start coming out until 3,500 to 4,000 RPM. So your timing will come in, but it'll come in at higher RPM. You can control that. There's also, on the underside, there's a nut right by the center shaft there, and under that nut is a bushing. And that bushing controls how far this plate moves. If I put a small bushing in there, the plate can move more. If I put a large bushing in there, the plate can't move as much. And so that allows you to control the total timing. If I put a big fat bushing in there, I might only get 18 degrees of total timing from, let's say I set the initial timing at 8, and then it only brings in about another 10, so I get a total timing of 18. Or if I put a small bushing in there, and this could move a lot, let's say I set the initial at 8, it could move a lot, and say my total timing is now 36 or something like that. So you can control that. So you've got adjustability on how fast the flyweights expand and the plate moves, and you've got adjustability on how far the plate can move. And between those two, you can set your advance curve with a good degree of adjustability and tunability. It takes a lot of practice to get it right, but you've got a lot of options. And so these are pretty reliable, but sometimes sensors do go. Sometimes the ignition box goes, but for the most part, they're reliable. Okay, and there's one last category or style for the electronic distributors, and that is the type that actually does have a Hall effect sensor. So it'll have 3 wires coming off the sensor, and those are what are categorized as ready to run or standalone distributors. So MSD sells their Pro Billet line, which is this, but they also sell ready to run or standalone distributors. And they're not the only ones. You'll find them marketed by other manufacturers as well. And the difference is those distributors can trigger a coil directly. They don't need an external box like a DuraSpark or a 6AL or any other MSD box. But most people who upgrade to an electronic ignition are probably going to upgrade the ignition box as well for a variety of reasons I'm not going to get into in this particular video. And then the last category here, this is our trigger. Now it is a distributor. This particular one has a distributor cap that goes on it, and it will distribute the spark to the various cylinders. It does not have any flyweights on the top like the MSD distributor did. As a matter of fact, by my thumb you can sort of see the gold brazing there. This plate, I'll hold the gear, this plate is brazed together so it cannot move. There's no advance option whatsoever for this distributor. Now the way this distributor works is it has a sensor mounted, and it is a Hall effect sensor, and this one is made by Fast Ignition. MSD makes a dual sync distributor. Holley does. There are a few others as well, and so how you configure them is a little bit different based on each, but one thing that's common to them is that there will be 2 triggers. So on this one, right by the wires, hopefully you can make out there's a 0 there, and there's a screw coming up through the hole next to it. And then to the left of the 0 is a threaded hole with no fastener in it, and to the left of that is the number 50. So right now the sensor is installed in the 0 position. This is a normal distributor position, so I could plug this in and I could plug this distributor into a fuel injection system and just use it to trigger top dead center like any other distributor. But the magic with the dual sync comes in this one when you put it at the 50-degree position. On the Holley or the MSD, you don't have to make any changes. It's already set up to work dual sync as is. You don't have an option to run it either way. It's just dual sync. But what do the 2 signals get you? Well, the distributor rotates once for every 2 rotations of the crankshaft. So cam spins at half the speed of the crank. So every time the crank goes around 1 full revolution, the distributor only goes halfway around. And so it takes 2 full revolutions of the distributor 2 full revolutions of the crankshaft to give you 1 full revolution of the distributor. And then for each 2 rotations of the crankshaft, when the distributor comes around 1 full rotation, at 8 points in that rotation will be when it is lined up to fire a particular spark plug. And so to run fuel injection, to run sequential multi-point fuel injection, and what that means, if you're not sure, multi-point means there's an ejector in each of the intake runners. So Ford intakes have 4 individual intake runners on each cylinder head, so there's an ejector in each intake runner, and so that's multi-port. And then sequential means that the injector only fires in preparation for combustion on that particular cylinder. So when number 1 cylinder goes down on the intake stroke, that's when the injector for number 1 will fire. So it injects the fuel directly into the intake lobe and down into the cylinder as the cylinder is drawing in the intake charge, and then the injector will shut off shortly thereafter as the piston comes up on combustion stroke. And it'll only fire the injector for the cylinder that is on the intake stroke. So that brings a lot of efficiency to the fuel injection system versus, say, the square bore type that replaces your carburetor. They just have 4 injectors that are just spraying almost constantly. So there's a lot of excess fuel being used, or at least sprayed, maybe not combusted. But with sequential multi-point or multi-port, you have a lot more control over when the injector is fired. And not only does that give you efficiency, but it also gives you power, because you have the ability to control when that injector starts to fire, how much it shoots, and when it shuts off. And having that tunability gives you a much more useful and complete system for controlling the combustion. And added to that, the fact that a fuel injection computer will also be able to control the timing. So all it needs to know is every time the distributor makes 1 full revolution, and every time the distributor is lined up with a post. So the cam and crank trigger signals that it gets off the rotation of the distributor are how it does that. And with that information, the fuel injection system will be able to, again, control the injectors and control the timing. And so you don't have to do things like play around with flyweights and springs and that sort of stuff to try and figure out a timing curve that works for your engine. The computer is going to do it, and it's going to do it constantly, and it's going to adjust it based on feedback from the oxygen sensor and a variety of other parameters. And you can actually go into the computer and control it. You can set up fuel maps, you can set up timing maps, and all sorts of things you can do to help the engine make more power. So those are sort of the 3 categories: your point distributor, vacuum advance, most reliable thing out there. Can't go wrong if you've got a completely stock application and you're just cruising around in it. If you are starting to try and make more power and maybe you want to go drag racing, test and tune, amateur, or whatever, MSD distributor is a good upgrade, or a similar distributor. Most of them use the magnetic pickup. There are some oddballs out there that use an optical pickup, but most of them use this type of pickup. And then if you're going to go fuel injection, you could use one of these distributors and go fuel injection. Just your options are limited. If you want to go with a full computer control for your engine and you want both ignition and timing control, you'll need a dual sync distributor for that. And again, this one's going to have a distributor cap on it, and I'll use it that way. But you could put a dummy cap on the top of here with no posts on it at all. And from the computer, you could run a harness to switch over to coil-on plug. So if you wanted to be weird and put coil-on plug on your old 289 or 302, you could with a setup like this, with this type of distributor or trigger and a fuel injection system. And a lot of the higher end fuel injection computers, like the Terminator X from Holley, have that capability. One other thing I'll talk about on the distributor, and that is the gear. Now, this Pro Billet distributor was in my 351 Windsor, and I want to show you the difference between the 351 Windsor distributor and the 289 302. Lining them up roughly the same here. They are pretty similar in design, but the main shaft here, this machine portion of it, is wider. It's the same up here where it fits in the block, It's got a little bit more meat down here on this one, but that's because this is the Pro Billet and this one is the stock. They're actually dimensionally the same all the way down to here. And the only difference between the two is the gear. So 289-302 has a 1/4 inch hex drive for the oil pump drive shaft, and a 351 Windsor has a 5/16. It's a little bit bigger. Here you can see them side by side. And so the only real difference between that is that the upper portion of the distributor, it's taller for the 351 Windsor. The deck height's about 1 inch higher on a 351 Windsor, and so the distributor is taller to clear that higher intake. But because all of this is the same, if I wanted to run this distributor on a 289 or 302, all I would have to do is drive out the pin that holds the gear on and swap this gear out for a 289-302 gear. Put that on, and I could put this distributor in a 289-302, and it'll work. It'll sit up really high compared to the intake manifold, but it would work. I don't know why you would want to, but I just figured I'd throw that in there, that it does actually work. I've done it before. You can't do it the other way around because the 289-302 distributor is too short. It'll hit the intake manifold. You won't get it down in, but it can work the other way around. The other thing about the gear is it depends on what type of cam you're going to use. That's what determines what type of gear you're going to use. So if you're using a factory roller cam engine, so a 5.0 from a Fox Body Mustang, for instance, you're going to need a bronze distributor gear if you're going to run a performance roller cam in there. But if, like in my case, I have taken my 289 and converted it to a roller cam using a Comp Cam's retrofit kit. The retrofit camshafts by Comp Cams are roller cams, but they're designed specifically to work with the stock iron gear. So if you use a retrofit cam on an older 289 or 302, you do not need to put a bronze gear in to run a roller cam. You only have to do that if you're running a late model roller cam. So those are sort of the basic distributor options. I mean, there are others, right? So like GM, instead of running the DuraSpark module external and having this big clunky thing, they designed an ignition module that goes inside the distributor on their HEI. It's got a big giant cap, and the coil sits on top of that, and then the module inside there does the job of a box like this. So they do have a sensor, an electronic sensor inside there. The sensor sends a signal to the module, and the module triggers the coil to fire it. There are aftermarket distributors that work. They're Ford distributors, but on the outside they'll have a GM HEI ignition module. Those are standalone as well. You don't need an MSD box or anything like that to run one of those. You just need the distributor with the ignition module on it and a coil. So you've got some options with the distributor. The best one for you depends on what you're doing. For an electronic distributor upgrade, I would say if you're doing racing, and a lot of racing, then definitely go with a distributor that is mechanical advance controlled. Vacuum advance can be tricky to deal with when you're racing because you're dealing with wide open throttle so much, and the one thing that you lose completely under wide open throttle is vacuum. And so it can be really challenging to set up a good advance curve on a drag racing engine when it's reliant on vacuum that you're going to lose every time you stop on the throttle. So But if it's your daily cruiser and you just stomp on it every now and then and you're looking to have fun, well, an electronic distributor with vacuum advance is a really good all-around option. Probably wouldn't recommend mechanical advance only unless you've got a lot of experience with that sort of thing and you're looking to take the vacuum out of the picture. So those are sort of the three options that I have direct experience with, and so hopefully this will help in. Oops. Hopefully this will help in some way in helping you to make a more informed decision over what your on what your options are, what type of distributor might work best for your application. There's a ton of information out there available, so I would suggest you just start reading, start looking things up on your own and finding out what you can. And if this helped you in any way, then I'm glad to hear that and hope you enjoy it. Thank you.